Hello everyone, we are going to create a ransomware proof of concept program that shows how ransomware works. This is not really going to be ransomware. You know what ransomware is. If you don't, it's time for you to do some research. So we're not really creating one. This is a proof of concept. Training purposes only. Only use this on your own computer. If you are not confident in your coding ability, I really recommend you do this in a virtual machine like Linux. Kali Linux already has everything built into it. Here is a cryptography library, and we're going to use Fernay. Fernay is an encryption library. We want to create some text files that have nothing in them. And I give directions on how to do that in Linux. I just created a bunch of text files with secret stuff and, stuff that's just weird stuff. I do like to do this in, here it is. Fernay is a symmetric shared key encryption library. So if you get ransomware, they say, if you give us, 5,000 Bitcoin, we'll give you the key to unencrypt it. Well, this creates the key. First thing we want to do is go to the end where we create our object. There's our Sauron object, because this is a bad program. We're going to get files first. We need to go through the current directory and see what's in there. List dir, list all the files in the current directory. This is a debug statement, just to show that you're actually getting all your current files. So before you do any of this, you could just run this part, see if you're getting all your files. Now this creates a list. See, a list of strings. We don't want to encrypt Sauron, which is the bad program. We don't want to encrypt Gandalf, which is the very nice white wizard program. And this is where we're storing our key that if they don't pay our money, we're going to keep this key and not give them to them. So we don't want to encrypt these files. Continue means that if these are found, we continue, which zips us right back up to the top of our for loop. If they are not files we want to keep, we are going to append them to our file list, and we're going to encrypt them in a moment. This allows us to debug what's going on. We get our file list. I am going to comment out this and see if that part works. I'll run the program. There they are. This is all the files. These three got skipped. These are the files that I'm going to encrypt. All right, next step. Let's create a key so we can get our files back or get some money for getting our files back. All right, so creating a key with Fernay, it generates a unique shared binary key. It's not text. You have to actually have the key file to do anything. So we're going to write the encryption key to a binary file once we've generated it. This is in bytes. It's a binary file. W means we're going to write it and overwrite any that are there. B means we're going to write it in binary. We open up this file as the key. We could call it the file. We could call it the file handle, whatever you want to do. And then we write the key to that little file. The key.key. Well, let's see if that part works. I'm going to delete, because we generate a new key each time. Oh, look at that. That's our binary key. That's hexadecimal. So I'm going to delete that, and we'll make sure this program works and creates our little key. And there's our list. And if we look over here, we'll see that we have, I don't remember what the other one has, but this one does look unique. Each time we run Sauron, we get another unique key. So run Sauron once you're doing the encrypt files before you run Gandalf. You could modify the program so you don't have to do that. This is just how I chose to do it. Now we're ready to encrypt. All right, we're trying. Sauron's got his wand out and he's ready to do bad things. In our file list, which we got here, self.file list, these are the ones we're going to encrypt. We're going to open the current file and read it as a binary, which means we don't care about the text. We're opening it in binary mode. Well, that's how we're going to encrypt it. We read the file into contents, and then we use Fernay with our key to encrypt the file into bytes. That's why we opened it as a binary file. Then we're going to write that file in binary with the encrypted contents. So we go through every file in the file list, open it up, read it into a binary variable, bytes, encrypt it with our key, and then we write that to the file. Well, let's run this and see what happens. Kapow! Uh-oh. 1,000 Bitcoin is a lot of Bitcoin, so we better do something. And there's our yet another key. And, uh-oh, we lost all of our stuff. Look at that. Oh my, everything's gone. What are we going to do? Sauron attacked. We're in trouble. Oh, look at here. Mr. Gandalf is coming around the corner. He can save us. Yay, Mr. Gandalf. So we use the same Fernay library. This one we're doing, I guess I could have called it Gandalf, couldn't I? Since I called the other one. I don't remember what I called the other one. Anyway, I think I called it Sauron. Well, I'm going to rename this. This should be called Gandalf, shouldn't it? Well, maybe not. I'll do that later. Visual Studio Code, if you press F2, you can rename everything with the name decrypt to Sauron. You can rename everything called decrypt to Sauron. Remember, programming languages are case sensitive. Press enter. Ah, we have a Sauron file. All right, I feel much safer now. First thing we do when we create our object, the init dunder method is a special method that when you create or initialize an object in Python, it runs automatically when you create the object. So now we've got an empty list. What are we going to do next? We are going to get the files. Oh, this is looking familiar, isn't it? So we list the directory. We print all the files. We go through them. We don't want to decrypt these because they're already decrypted. Remember, this looks familiar. We continue and go through the rest of them. We're going to add files, not directories. See, it determines, is this a file? We're going to append each file to the list. At the end, we get our file list. So let's see if that works by commenting these two guys out. Okay, here we go. Yep. These are all the files. These is just the files we want to decrypt. Work just like the other program. All right. Well, the next step, before we can decrypt, we have to read our key. And there's our self-secret.key. We read the encryption from the file into a variable. Oh, we should print that out. So print. And yeah, this is not very secure, but we'll just call it secret key. Uh-oh, somebody forgot his F string. Secret key. This is a debug statement because you're never going to actually print out the secret key. So self dot secret key. There it is. And let's see, I'm missing this guy. There we go. So now this should print out our secret key. Let's see what we get. Look at there. Our secret key. All right. We'll put a little note in here that says, for debugging only, which means you can comment out when you're done. So this is called print debugging. Oh, it can be commented out later. It's just a real quick and easy way to see what's going on in your program. Now we're ready to debug the files. Well, Gandalf doesn't want to be used by anybody. We need a password to run the decryption program, and if I had spelled decryption right, that would have been nice. So, if you dare to enter the secret phrase, if the user phrase equals a secret phrase, we go through each file on the list, we open them up, we read the contents into a variable. This was very familiar. The difference is, this time we're going to decrypt the contents. Then we write the file as a binary, and once we're done with that loop, everything is decrypted. And if they didn't give us the right secret phrase for the decoding program, well, we have to send more Bitcoin. Well, let's see if we have to send more Bitcoin. It's like, what? There's a secret phrase. Let's just do secret phrase. Uh-oh, we have to send them more Bitcoin. Well, I sent them more Bitcoin, and they gave me the secret code for the decrypting program, which is GANDOLF01. At least I hope it is, or I have to send them more Bitcoin. Oh, goodness gracious. Thanks for all the fish. And we're back. There it is. That is a proof of concept how ransomware works. This is not meant to be used for malicious purposes. This is educational only, which you already knew that. Well, now we know how ransomware works in theory. There we go. See you later.